Today we're looking at notes AA-3, Law of Sines, No Solution. So first we want to refresh what we did the last day. So solve the triangle if possible. So given angle A is 60 degrees, side A is 9 units, side C is 10 units. I've drawn the triangle here. So angle A is 60 degrees. The side that opposes it, side A, is 9 units. That's a 9, not an A. And then the side that opposes angle C is 10 units. So then we needed to find angle B, angle C, and side B. How did I get these numbers? So finding angle C, we used what was given to us, the two letters that matched, the little a and the big A. So side A was 9 over sine of angle A, which was 60 degrees, was equal to, and the reason we had to find C first is because C was the only one that we had some information on. We had the side C on angle C, but we didn't have what side B was, so we had to find C first. So side C was 10 units over sine of angle C. That kind of looks lowercase. Let me just make sure you can tell it's capital. Okay, and so then we cross multiplied, of course. 9 times sine C, it's supposed to be capital, it doesn't really look like it, is equal to 10 times sine of 60 degrees. Then to get sine C by itself, we divide by 9, plug this guy in the calculator like I've been showing you with the alpha y equals key. You get, 9s are gone there, you get 0.962. So then, of course, to get angle C all by itself here, you want to sine inverse or arc sine, whatever you call it, either way, on both sides. So you have sine inverse of 0.962. You plug that in the calculator, and you get 74.207. And, of course, like we talked about, you want to round up when thinking about if that second triangle exists, because better to be up, round up, than round down, because you don't want to think that there's a possibility for a second triangle when there's not. So the angle whose y value is 0.962, it does make sense, 75 degrees, it's high because it's real close to the 0.01 right here. So if this is 75 degrees, remember if you back up from 180, back up 75 degrees, that would be 105 degrees. So then we test the possibility of that second triangle. We add 105 degrees to the given 60 degrees, and that is definitely less than 180, so that second triangle exists, and we'll complete that in a minute. Okay, but let's finish off the first triangle. So in that first triangle, we already found angle C, then we had to find angle B. So finding angle B, we know that all sides of a triangle add up to 180 degrees, so 180 minus the 60 degrees given, minus the 74.207 from angle C, and that gives us our angle B, 45.793 degrees. And then to find side B, finally, you're going to use, again, what was given. Side A, angle A, is equal to, using the law of sines, side B over that angle B is 45.793. Okay, cross multiply. This is what you get. You want B by itself, so you divide by sine of 60 degrees. Divide by sine of 60 degrees. You plug this in the calculator using the alpha y equals key like I've been showing you. All right, and then B equals 7.449 units long. So we did state that that second triangle does exist. It does exist, so we have to go further. So remember, now we need angle B2, angle C2, and side B2. So to find angle C2, remember this 180 doesn't come from the knowledge of a triangle, it actually comes from the unit circle. We want to find the pure angle C2, not the rounded one like we have here. We want to see if you back up 180, if you back up exactly, well not exactly, but more close than what the rounding is. If you back up that 74.207, okay, and get a more pure answer, our angle C2, instead of rounding to 105, it's actually 105.793 degrees. Okay, I'm going to box this already just so it doesn't get confused with what's here. Okay, so now we have angle C2. Now we need to find angle B2, and this 180 degrees comes from the knowledge that a triangle's angles add up to 180. So 180 degrees minus the given 60 degrees, okay, minus the 105.793 that is angle C2 equals B2 is 14.207 degrees. Okay, now we found angle B2. Let us find side B2. Okay, so side B2 comes from our knowledge of, again, A. Little a and big A were what was given. So that would be 9 over sine of 60 degrees is equal to our B2 over angle, sine of angle B2, sine of 14.207 degrees. So then we will cross multiply. So B2 times sine of 60 degrees equals 9 times sine of 14.207 degrees. Okay, we want B2 completely by itself, so divide by sine of 60 degrees, divide by sine of 60 degrees. And then, of course, we get B2. When you plug this using the alpha y equals key in the calculator, we get B2 is equal to 2.551 units. And again, that should make sense because remember, that smallest angle opposes that smallest side. Okay, and then the largest angle opposes the largest side. All right, so that was number 1. Now let's move on to number 2. So now given angle B is 75 degrees, side A is 5, and side B is 4. So if you need to see the triangle, so angle A we don't have, angle B is 75 degrees, side B is 4, side A is 5, and side C, or angle, well, both angle and side C, we do not know. So we want angle A, we want angle A, we want angle C, and we want side C. Okay, so find angle A because we have side A, we don't have side C. So we'll find angle A first. All right, using our law of sines. So for what we do know is side and angle B. So 4 over sine 75 degrees equals 5 because we're looking for angle A and that's little a. So 5 sine of angle A, and then cross multiply, and you get 4 sine angle A equals 5 sine 75 degrees. And then we want A, so divide by 4, divide by 4. You plug this sucker in the calculator, you get sine A equals 1.207. So then angle A equals sine inverse of 1.207. Okay, and what happens when you type sine inverse of 1.207 in the calculator? Okay, so it tells you error. Why does it tell you error? Well, think about it. Again, I've kind of tried to emphasize this, but let's make sure you understand in case you don't. We've been dealing with the unit circle all along. This means the angle whose y value is 1.207. This point is 0, 1. It is the unit circle. 1.207 is not on the unit circle. So that value, let me make sure I clearly am pointing to this value, is too big. It is greater than 1. That can't happen on the unit circle. So I'm going to cross through this. I'm going to put no solution, and I'm going to box that because it's not possible.